Alright, so this is question 7 of the homework. So for A, it's asked us the friction to stop it from sliding. If it's not sliding, then we must use static friction. And for any box in a ramp problem, draw a free body diagram. You'll find that the normal force is equal mg cosine theta because it's adjacent of this angle. Note that these two angles are the same. And then the force sliding down is mg sine theta. Note these two are the same. I just drew them so it's clear because it's the same theta, same direction, same magnitude. So then we know the formula for friction, which is just normal force times the static friction coefficient, and that's mg cosine theta as we just found here for the normal force. So then you plug in your weight, your mg essentially, and times it by cosine theta, and then the static friction, you get your. So then this is the force that friction can oppose at most. But then we need to figure out what the force of the box sliding down is, this mg sine theta. So then you just plug in your weight for mg and times it by sine theta, and then you should get a bigger number. So if we want this thing to not move, the friction force needs to equal the force going downwards. And so notice that the force going downwards, the friction force would be going up because friction always opposes movement. So this force of F right here plus the friction force needs to equal mg sine theta. So we need to find the difference between the force that's pulling it down and the friction. And if you just subtract it, you get some number around there, and that's A. Now B, this question is brilliant. It really makes you have to understand when to use static and kinetic friction. So we're being asked when the box is at a constant speed what friction is needed. Note that the acceleration is still 0. And then note that it asks for minimum force to start moving. These words should stick out to you, especially the start moving. For this question, we still have to use static friction, even when they say moving. But why? Because for it to start moving, it needs to first begin from not moving to moving. It needs to pass the static friction. Threshold. It's true that after it starts moving, the force that you need to keep the same velocity is less. But this question's only asking for the start. If it said keep moving, you would use kinetic friction. And then you have to realize, while in the last question friction was helping us, in this case friction is now opposing us. Why is it negative basically? Because the box is now moving up. In the previous problem, the box was going to slide down. So now that the box is moving up, friction opposes us, and now friction is going in the other direction. However, the normal force and the magnitude of friction stayed the same. So instead of subtracting each other, just add them. And then that will give you B. And then for C, remember if I said if they ask for keep moving, you use kinetic friction. So then you use the same equation, but for static friction, instead you calculate kinetic friction using mg cosine theta times uk instead of use static friction, and that will give you the answer.